Alright class, this is the second tutorial to go along with the assembly process for our fabrication project for the semester. So where we're going to pick up here is we've just baked all of the unrolled hex components, and we just baked all of the trimmed surfaces that came off from our original component here. And what we're going to do at this point is talk about how to connect back to the 2x4. We're going to apply some color to this. We're going to talk about how to unroll some of these surfaces, the flat surfaces, so that you could create them out of either cardboard or cardstock, or we're going to experiment with some different materials so that you might be able to apply color to them. So I'm just going to go ahead and bake these guys again if you haven't already. That's going to be the first step in this next piece. So the tool here for unrolling these is actually, if you type in unroll in Rhino, you'll see quickly that you can't unroll doubly curved surfaces, and so these, because they're part of that original surface, you can see they're doubly curved. It doesn't mean we can't necessarily use them though. There's another tool in Rhino called Smash. So I'm assuming that I'm going to use number 21, probably number 22, number 4, and number 9 as my surfaces here. So I'm gonna I'm gonna attach to with rope to hold this surface up off the ground. So I'm gonna hit enter and hit OK for that first surface, and you can see it's placed it down here on the ground as a flat object. I'm gonna copy the dot down onto that object so that I've got some way of identifying what's what on each of these. So there's number 21. Let's do smash again here on 22, and I'm going to move it over underneath. Same for number 4. Move it over underneath the location for 4, and same for number 9. And then again, I'm going to take these dots and copy them down onto each of them so I can keep track of what's what. Okay, so with that done, we're ready to move back into Grasshopper. We're going to talk about how to manufacture some of these smashed surfaces. Talk again about some color and about connecting back to these other objects. So I'm just going to pick up where we were with the Grasshopper script from the other day. If I can get Grasshopper to load. I'm going to have to pause and restart Rhino here. Okay, got to fire back up here, getting Grasshopper fired back up. And get my script open back up here. Okay, so again, this is based on the first tutorial from this week, which walks you through how to create a loft between two sets of hexes, filtering out the incomplete ones around the edge, using the unroll component and the orient tool to unroll and then lay down and spread out all of the different parts for fabricating the hexes, putting tags on them, baking the tags. Down here, splitting the surface, again filtering out the remainder components that are left over from the split, cleaning them, and this is where we're left. So we've been using the gradient tool to apply color all semester, and we're going to do that once again, and this is almost always linked to a distance or something to that effect. So we're going to use distance again, although you in your own design for this for this installation may choose to do something other than distance with it. I am going to just turn off some of the layers here so we can visualize this a little bit better. There we go. I need to put a point in to measure the distance from, so this is sort of like an attractor point. I'm just going to say set one point. Doesn't really matter where. I mean, it may matter to you once you go to start designing with this. And then an area component will give us centroids that we can measure off of to create the distance. So again, this distance is going to be the thing that drives the gradient color for each of the panel shapes. And of course, we need a preview component to apply that color to the original surfaces. And I'm going to set this over to one of the fancier color schemes. So in order to get the distances working, we can either remap it between 0 and 1, as we have been, or you can leave the numbers where they are. They don't need to be compared with anything else, but you do need to get the domain. So we're going to use a deconstruct domain component, and we're going to use a bounds component. So the bounds basically gives you, we've been using this before, but this gives you the maximum and minimum value for your distances. We do need to flatten these in order to get this to work. The deconstruct domain takes the max and min and gives you a start, which is the lowest value is 107 and the highest value is 189. And those become the start and end, your L0 and L1 for the color gradient. For some reason our colors did not. I think the flatten actually needs to be applied back here to the surfaces. It doesn't hurt it to be on the distances as well, but now you can see that color gradient. And of course we can go back into the gradient here with presets and kind of change it to whatever kind of color scheme you may want. So that's a good way to start visualizing these panels as part of the construct. The next thing that we want to do now that we've unrolled these components and laid them down on the ground is to actually create some drawings. So we're going to hold this whole thing together with binder clips. So we're going to create yet again another script based on these surface components that will allow us to actually create the drawing we need to binder clip these surfaces to the inside of the hex. So what we need is a little edge, a little 3/4 inch edge around the 6 faces of this that we can binder clip to the edge of the hex shape up here. So first thing we need to do for this script is bring in a surface, bring in one of these surfaces. I'm going to just say set one surface, and we're going to deconstruct it and get the edges. Basically exploding the object. So deconstruct brep is sort of like exploding it. We're going to offset these edges as curves. So each of the curves will get offset 3/4 of an inch, 0.75. We'll put that into the distance. And you can see what's happening here is we're getting each of these edges moving out. What we want to do is actually go ahead and create surfaces so that we can join all of this stuff together in order to make the boundary shape. So in order to do that, what we want is to once again do the entwine component because we're leading towards a loft. We want to basically loft between the edges of the hex and their new offsets. So I'm going to put these two sets into the same entwine component. Again, I can come in here and remove one by hitting the minus. We're heading towards a loft, and as usual, we need a flip matrix whenever we use the entwine component to get things broken out. If that's confusing, go back and take a look at the last video, and I'll explained it a little bit more in that one. So here's those lofted edges, and now what we want to do is a region. Rhino is a region union. So this is basically going to take all of these objects and allow us to join all of them together. So the region union is so what we're going to get is just this outside boundary of each of these objects all the way around. The region union is looking for curves in order to join them. This is kind of like the curve Boolean tool inside of Rhino. In order to get this, we need to extract the wireframe. So I'm going to put in the brep wireframe. And it's going to give us the edges we need for these components. The other ones that we need, so we just took those, and then we need the original surface as well. Actually, I think we can use just these edges here. So I'm going to put a join curves component on these edges. That creates one of the curve shapes that we're trying to union. One closed planar loop that goes all the way around the object. I will turn the preview off on some of this, and hopefully that'll allow you to see it a little bit easier. I'm going to also hit hide in Rhino. So now when I select this, you can see the green edge all the way around. And same goes for these wire components. We need to join them so that they operate like regions that we can then union together. So I can hold the shift key down and take all of these objects. And again, I will turn the preview off on all of this so you can see. I need to flatten that. Isn't exactly what I was hoping for. Let's see if I can get this. So again here, just a flattened component needed, and now we've got the edges offset out. So this is the panel that you would then laser cut with the edges folded. In order to get a dashed line along here, we're going to use one of the simplest components in all of Grasshopper, just a dash of these edges. What it's looking for here is a set number. So you can set multiple numbers and that will change the distance between. So this, if I put a 1 and then a 2, it's going to go 1 inch with one dash and then 2 inches with a gap. You can see what that looks like, where the gap between each dash is twice as long. Or if I just say set number and just put a 1 in, you can see it does 1 inch on, 1 inch off, which is just about right for what we need. So basically this is a solid laser cut drawing that we can bake. I'm going to group that and then bake the union. And now what we've got here in Rhino is a drawing that's ready to go to the laser cutter for manufacturing one of the rigid panels that's going to get tied back to our surface. Okay, so that's one component of this. The other that we want to do with these surfaces is we need to draw the curves back to the 2x4 so that we know how long the rope component should be from each of our objects. So I'm going to take this area component right here and bake the points. And what that's going to do is give me a point here. So if I remember right, I'm using 21, 9, number 4, and number 22. So I'm just going to select the points from the 4 panels that I'm going to use, and I'm going to bring those back into Grasshopper. So set multiple points. And what we want to do is find the line that goes back up to the 2x4, to the center of the 2x4. So we need to get a curve or some kind of centroid on the 2x4 here. So I'm just going to draw a curve, bring that curve in to Grasshopper. Just drew a rectangle on the very top of it here. And what we can do then is get an area component to get the center. We're going to move it down from the from the very top, so that centroid is going to go 12 inches down in the Z. And since we're going down, we're going to need to, looks like, no, we're not. We're going to need to put an expression on this to make it go backwards. So we'll put minus 12 or minus X into this component to make it go down. So there's our the the point that we're going to tie each of these points back to. And then all we really need here is a line component that's going to go from each of our objects that we're tying back to up to this one. And really for manufacturing this, all you need is the length of those lines. So I can put this in along with a panel. Now if you wanted to visualize these, you can also put a pipe component in. So here are the 4 lengths of the ropes that we need. And if I wanted to, I could put the pipe in just to make it look visually better. So that would be the visualization of each of our ropes going back up to the mast or to our tree in the middle. So those are the 4 other components that I wanted to go through. So we have a completely separate script here for getting the rope lengths back up to the 2x4. We've got each of our 4 panels. If I take one of these surfaces and swap it in, set one surf, I can generate the drawing by baking these 2 end components, the dash and the curve. And if I hit hide here in Rhino, you can see this number 22 now is ready to be cut. And same goes for these other 2 going across. So the last part that I want to do is to write a little script. Basically, for these panels or for the unrolled hex shapes, we're going to bring them back in to Grasshopper, and I'm just going to say set multiple B reps. So as we're connecting each of these, and I'll try to explain some of this again later, what we want to do is actually try to offset where it is that we're binding each of these shapes together. And we're also going to need to, again, create kind of an offset edge where the shapes are. So we're going to write a little script here that allows us to connect the hex, or basically finish off the donut or close the donut in an appropriate way.